There we go.
And if you guys could also put your school in the chat, that would be helpful for attendance.
Thank you,
Good
Connie. Sorry.
afternoon, everyone. Thank you for attending this recovery webinar. I'd like to follow up with a statement here. The following recovery presentation represents the standard aspects and skills, practices used and performed with success by the high power rocketry community. If any techniques or standards are in question, please take note and bring it to the presenter's attention at the end of this webinar. Thank you. Today, well, I think this is Rob's introduction right here, I guess.
Yep. Just to let you guys know, in case you're sitting in fresh for your team, from the Wisconsin Space Grant Consortium, Kevin Crosby is our director. Christine Bowles is our assistant director. My name is Rob Cannon. I am the project manager for the competition. Connie Engberg is our amazing support assistant, helps make sure that everything's turned in on time. And then from our technical team, Frank Noble here is our representative for Tripoli. We also have Mark Abbas-Hossaway and Brittany Nez, who are the project assistants for the Moon and Mars challenges. And then you guys will get to meet Bob a little closer to launch weekend. Thank you.
Okay, rocket recovery summary. We're going to go over rocketry profile on its flight and how it should perform. It all starts in the avionics bay, of course. Your wiring, battery, and other components. You should be learning about your altimeters. Types of hardware to anchor for anchor points and connections to your rockets, internally and externally. Deployment hardware and techniques, which includes black powder, canisters, and your little tubes to deploy your recovery system. And how to achieve a safe recovery. Of course, that's the buddy system, and you always bring someone with you and always watch your rocket where it lands. And of course, locating your rocket with your GPS. Oops. Rocketry flight profile. Laws of motion are quite prevalent as the rocket takes off. As you see in the bottom here, I don't know if you can see or my cursor here, we have a power liftoff and the world is on the individual's shoulder. A body at rest persists in a state of rest until the body in motion remains in a constant motion along a straight line unless it's acted upon a external force, which is your earth right here on your shoulders. And as the motor burns out, you have another external force. You can see this individual's hat kind of flew off his head right here. So you have an opposite reaction from the action of the motor burnout. And as the rocket cruises into the coast phase at apogee, the drogue chute opens and another reaction happens also. Whatever you have inside your rocket must be secured, like your avionics bay, your rocket sled, your batteries, and your recovery harnesses. They will all shift, especially your recovery harnesses. And of course, as you descend under your drogue, the recovery descent phase comes down to your main chute deployment. Everything happens again. There's more motion in your electronics. You got to make sure all your components, your payload, your batteries are still in a state that they left the pad, so they operate properly. Oh, let's see, slide number 4. Let's see, we have avionics check. The use of the recommended, it is always recommended to use fresh batteries. I don't know how many times you tested your rocket at the launch or before you come to the launch. Try avoid using the same deployment method that you use with the same battery. All redundant recovery systems must have a separate independent altimeter and power supply, along with the energetics. The energetics, of course, are your deployment charges. Securing batteries to the deck of the avionics sled is essential, as I mentioned in the slide before. Securing, primary battery connections should be doubled up and securely down as it shows with, I have electrical tape around the battery holder, plus a tie wrap to hold it from going left and right and up and down. You can put a tie wrap on the vertical position too, if you wish. And here we have a LiPo battery right here in a 3D printed envelope right here. It's all it takes is one little slip of this nut right here, and it'll come out for easy insertion and removal. And of course, we have extra terminal boards here for your featherweight if you're going to be using one. Always mount altimeters using a non-metallic standoffs, which is right here circled in the lower corner right here. Always use non-metallic to avoid damaging the delicate components on the underside from being crushed, because there's small little integrated circuits underneath your altimeter of all altimeters, and you do not want to crush them, so you will need standoffs. Assure wires are secured to the altimeter as shown in figure 2 right here, and I have the you can see as the wires are securely tied down with tie wraps, so nothing moves. Always use a gentle pull and tug on the Phoenix connections after you've tightened them down. Standard wire that should be used for your altimeter should be 18 or 22. Those are the most basic type. Do not use solid wire, use stranded 18 or 22 wire. You can use a ferrule to squeeze the end of the wire onto the connection, or you can tin the ends of your wire into your terminal if you want to. Do not solder the terminal to the wire. Tin the wire like I show right here, so it has a good connection, so there's no strands hanging out. Not necessary.
There's the other reason for having that gap underneath the altimeters is some of them will have their barometric pressure sensor mounted on the bottom of the board. So you want to have a free airflow path to that. And you don't want to jam that up against your circuit board and cut off the airflow to it.
Right. Yeah. Never choke your altimeter.
Bad things happen.
Yep. Underside of is the program audible sequence of the altimeter too. Always understand the sequence of your altimeter. Once you have initiated the power to the rocket using your switch, always understand the sequence of your altimeters. This weekend I had a launch and we had 4 rockets up on the rack next to each other. And the students said, well, I can hear my altimeter beep 3 times. You know, it looks good. I go, no, you're hearing the other rocket making the same noise. So be aware of that, please. And lucky they took the rocket down, fixed the problem, and had a successful launch after that. Wire it right. This is a typical RRC3 altimeter I'm using right here. Always make sure to wire it right. Make sure you wire your drogue at apogee, and you can either color code your wires or just tag them which way they go. Of course, then we have the main chute wired properly, and we use an on and off switch of your choice. Avoid using twisted wires to turn on your altimeters. Sometimes you'll have brownouts, or you might have accidental premature ejection right at the pad, possibly, if you jiggle the wires on and off as you twist the wire. It's not a very good connection, and I don't recommend it. Older experienced people sometimes use it, and it's been successful for them, but I do not suggest you use twisted wire to turn on your electronics. Of course, always review your owner's manuals for proper functioning and wiring of all electronic devices in your rocket. And like I mentioned before, if you are in doubt as you turn on your rocket at the pad, ask the pad manager. And the pad manager will assist you in taking that rocket down and back to the prep tent.
And whatever switch solution you come up with, make sure you can disarm it just as readily as you can arm it.
Okay, restraint hardware. They make an array of restraint hardware. Pretty much most of them work. There's some you should stay away from. Some quick links are stamped with the rated weight limit load on them. And usually your standard zinc quick links are okay. They're basically the quarter-inch ones are good for 875 pounds of pull on the weight limit. And the weight limit is just something that is not actually jerked and pulled for a load weight. It's how much it'll hold as you lift it up. And in the competition we're having, 875 pounds should be quite substantial for acceptable for your rocket. As you can see, the basic weight of what are we looking at here? Number 10, you have a swivel. I would suggest that you do not connect that to a load binding part of your rocket, like a bulkhead that holds the weight of your rocket or contains a shock as it deploys. I recommend those to stay at the parachute by the shrouds and the connection to the recovery harness. And swivels are quite useful for your parachute, for your rocket not swinging around and around and around. And of course, the U-bolts on number 7 and 8 contain 1,500 to 2,000 pounds. I recommend these type of connections. They're very strong because if one fails, one is still holding. I know a lot of mentors and other people suggest these forged eye bolts. They work great for the competition that we're going to be using, but you can see the galvanized eye bolts are only good to 650, which is fine for your mid to high power rockets that weigh between 10 to 18 pounds. And of course, it only has one holding pattern right there for one bolt, but I recommend U-bolts. You can put these in 4-inch rockets very comfortably. They fit real fine, and they probably cost about 3 times less than a forged eye bolt too.
If you go the eye bolt route, do not get the ones that are only bent. Make sure you get ones that are either forged or welded.
All right, it says right here, avoid using open eye bolts or eye bolts. Their ratings are only 70 to 100 pounds. I think I could probably break one of those things open. Basic rocket parachutes. Safety codes of both NAR and AAA and the National Fire Protection Agency require that all high power rockets may be flown only if it contains a recovery system. That, of course, it'll return all parts of the rocket safely to the ground and be flown again. In this picture here on the left here, we have the basic elliptical parachute that everybody uses. It's a very fine parachute for descent rate. Parabolic parachute, fancy. It does the same job. The X form, basically for a drogue chute or lightweight rockets, probably low to mid power type rockets. Of course, your parachute descent rate. I have a formula right here is basic from NASA. You can do all the math that you want to do. A rocket apogee under a small drogue chute using dual deployer requires a descent rate of about 50 to 70 feet per second. 34 to 47 miles may seem not very fast, but it is. It's pretty fast. It's enough to take your finger off if you grab the rocket. Of course, do not grab the rocket as it falls. I expect that your rocket be built to withstand a drogue descent. And deployment of the main chute of any altitude should have a descent rate of 15. It's 30 feet per second now. They raised it up a couple of years ago. I don't know why. I'm thinking because some flying fields are smaller, so they raise the feet per second on most of the descent rates on the main chute. Observe the velocity formulas below. You can use the one on the left, or simply when you have your open rocket open, it'll tell you the descent rate by using a certain size chute and a certain type of chute from the database that you picked it from. That's pretty simple. Or you can do your profile launch in your RockSim, and it'll tell you what your descent rate is during your flight on your test flight. Types of rocket and recovery harnesses. A lot of people have different feelings about certain harnesses. I've used all 3 or 4 of these types. I've flown impulses up to O's, and they've worked pretty good, especially the Kevlar. Tubular nylon fax, 1-inch wide braking strength on a tubular nylon harness, which is used for climbing. Has a 4,000 pound and it's military grade. I use these excessively and successfully. They're easy to tie and untie by hand, not by a failure. And we'll get into tying knots here in a little bit. Kevlar straps, they're very heat resistant. They're very strong. You get one stuck in a tree, you end up taking the tree down, not your rocket. Related to aramids, such as Nomex, the 1/2-inch wide has a 1,500 pound braking strength, created by this person here at DuPont. Very heat resistant aramid synthetic fiber with a molecular structure of many interchain bonds that make Kevlar. It's very strong. Flat nylon webbing, it works okay. It's not the best, but it'll do the job. 3/4 inch wide with a tensile strength of 3,800 pounds. It's easy to tie and it's easy to untie. Moderately heat resistant, but you must inspect it after each use because it's not resilient to heat too much. It kind of melts a little bit, so you got to watch out and protect it, of course.
The big advantage to Kevlar is the heat resistance. The disadvantage to Kevlar is not about the braking strength, but it does not stretch. So it will tend to hit harder. You need a longer cord to absorb that. The nylon, protecting that from thermal damage from your charges. I've had one instance where my charge hit the cord and completely cut it. So you have to protect that from the fireball from the ejection charge when it's going off.
Correct. Thank you. Yeah, that's one thing. I'm glad you brought that up. We want a little bit of give on the shock cord. We want a little stretch. Like I was mentioned, Kevlar does not stretch at all. And if you get into catastrophic type deployment, either early or late, parts may fall out of your rocket. Excuse me. Harness length. Length of recovery harnesses, especially during the apogee deployment phase, should be 3 to 5 times the length of the rocket. Providing this length will ultimately cause drag as the harness unravels out of the airframe, especially at apogee. It'll reduce the velocity of the rocket during deployment. Too long of a recovery harness like this one on the left-hand side could be advantageous to your rocket because your rocket could deploy at a slow velocity at apogee and everything falls out. If your rocket is heavy enough, the booster will actually just drop like a rock and pull on your chute real hard in the rest of the recovery harness. And it could, parts like your bulk plate or a U-bolt or something could fall apart or bend out. And possibly cause of course, a zipper.
Yep. And the Kevlar definitely, if you decide to use Kevlar, definitely go towards the 5 times the length rather than the 3.
Yep. Here's just a simple avionics bay. Here's a side view of one. Of course, here's the your switch. Here's your vent hole for your avionics to breathe, think, and talk. And of course, this part here, some of you might have ordered the stiffy tube for your avionics bay from Lock, which fits inside the coupler. And of course, then you have this, whoops. And you have this a recessed type advantage right here with your bulk plates on each end, and they all kind of tuck in inside your avionics band, your coupler. And of course, here's your optional canister deployment cans that you put on your bulk plate for your apogee, and you have one for your main. And then, of course, we have a top view of the sled, which is through a threaded rod, tightened up with nuts. Of course, you want to keep this as steady as possible. You want any action happening until the rocket takes off. We do not want any of your sled loose. It has to be rigid and mounted along with your electronics and your batteries. Of course, here we have our classic U-bolts to hold the aft end of this avionics bay for apogee. And we have the U-bolt here, or your I-bolt, whatever you want to use, for your main. And this does not show where the deployment charges are, but this is your basic deployment charge up here. 3D printed eBay sleds are becoming quite popular. They have a lot of programs out on the web to download a eBay 3D printed device if you want. Very useful, very slick looking. You can mount your switches permanently in one mold, so you don't have to mount it to the airframe. The middle one is your basic, pretty close to LOX design. And then on the right here is another 3D printed device here. And we have all kinds of little links right here that you can download programs for 3D printing. The altimeter sleds, Additive Aerospace has 3D printed sleds to your liking. You give them the dimensions and they'll make one for you.
That bottom left picture there has a good example of two of the most common switches that are used. You have like a Schroeder style switch, the black ones, and then a screw switch. Common place to get those are Missile Works and a number of other places. But those are both good options for switches.
I've gone into the close proximity type switches they connect right to the body of the airframe, and it's very close quarters. Like these here, these black ones, I use them too. They don't have much clearance inside, so when you're sliding your AV bay or something in there, you might hit it possibly, but that's all part of the design, and that's part of the hazard of putting in switches because they're pretty deep. I found these low clearance ones work very well. There's not much on the back of them, so no worry about nicking off a wire.
That's my go-to are those screw switches, and I present them out to the vent holes, relatively close to the vent holes, so it's real easy to get to them with your screwdriver.
Yeah, I know. I've watched I watched people spend like 5 minutes trying to find that screw. Yeah.
Yep. So if you bury your switch deep, just a heads up there. You can spend a good bit of time and effort fishing around in your bay trying to get your screwdriver on the screw, or if you have a push button or something like that, you fish around trying to find the button. If you can make them, present them up to your vent holes closely, not so close to interfere with the airflow, but if you can see that from the outside, it's there you go. So now you get your screw right there, and you don't fiddle with it. It's quick. You know exactly where it's at.
Yeah, I even happened to find a brass screw for it, so good. So it gets good connection. Okay. Okay, deployments. Typical dual deployment rocket using this is a satellite deployment instead of the canisters. You can wire your deployment charges by using Wildman makes a lot of these type cardboard deployment charges. I'll show it later in the video here. Make sure I just secure the wire as it goes out. You can see this one's for the main on the left here, and then to the right is the drogue. I just call them satellites because you're stretching the deployment charge to the back of the aft end of the rocket. So as your rocket goes up, it pushes all your deployment devices out, your drogue and your and your strapping. Same thing on this one here. It blows the nose cone off and it blows out your recovery and main chute. One advice though, we use redundant systems. Usually there's two in here and two back here. And I know in the past, a lot of the teams use redundant systems. Now, a redundant system means that if one altimeter does not work, the other one should take over or compensate for the one that didn't work. It has nothing to do with the charges, because if a charge goes and it leaks part of it open and it does separate your rocket, but your chute comes out halfway, it doesn't mean the other altimeter is going to work and push it out, because there's no pressure available sometimes to push the other chute out. So that's the reason for a redundant system. In case one altimeter fails to operate, the other one can operate properly while the rocket is together and perform a proper deployment charge. And of course, down here on the lower left, we have the head-end dual deployment. I've seen this happen many times. I've got one rocket that has it, and it's successful. It's tight quarters. You can't put a real huge parachute in it, and you don't fly a big rocket in it either. It's usually a 4-inch or smaller rocket that you use head-end deployment in case you need more room for your avionics or sensors, which is a good idea, which is where we're going to be doing this year. And this video right here that I have on a link is a very good video on how to set up a front-end deployment. That means the electronics are in this AV bay part right here, and your parachute's in the nose cone, so it comes all flying out at your programmed altitude for your main. Here we have recovering ideas. We have the Y harness here. If you have purchased a cardboard type airframe, this works good for not zippering severely the airframe. Figure 2, of course, the harness is epoxied to the motor tube with the Y harness. You can use the same thing, the Y harness with the motor tube, which is shown right here in a sense. And this way here, you have two straps coming out of here for more security and less zippering effect. And of course, we have the standard single harness in figure 4. I'm kind of weird about recovery harnesses failing. So this is one of my rockets. This is a 4-inch rocket. It has 2 U-bolts connected to the forward motor mount ring. And I usually use 2 straps generally. I don't know why, that's just my thing, but it doesn't have to be yours. And of course, in figure 5, we have the Y harness that comes through the notch of the motor tube. And these are basically probably more or less 4-inch, smaller type rockets where you don't have enough room to put a U-bolt. Harness comes through the notch of the top centering ring, and both ends are epoxy to the motor tube, just like shown right here.
And that gluing to the motor tube, epoxy to the motor tube works great, but you definitely, I would steer you towards Kevlar, at least for that portion of the harness, because they're very difficult to replace if you have damage to them.
Right, because nylon and epoxy sometimes does not mix well after a few times, and it starts degrading.
Yep. But you can make a Y harness, a single strap or a Y harness out of the Kevlar. And then, like in figure 1, at that attachment point, that's where you start your nylon.
Yep. Okay, so standard payloads and nose cones. Improvising a good connection with polystyrene plastic molded nose cone may need probably extra attention. They're not made very well. These are especially from Lock or Mad Cow or Apogee. These little tabs are pretty weak, especially if you're going to be deploying a rocket at Apogee. Your rocket is undergoing some pretty good velocities. Not recommended to use these type at Apogee. I've modified. You can see this one here. This tab's been broke already. So I strung a and sewn a strap in here. Just made slots in the back end of it. Very secure, holds it very well. Same thing with this model right here. I just drilled a hole through the heart of the mold ejection part there. It's pretty strong with a quick link. This one here, these are pretty lousy tabs, but they work pretty good. One fails, one will still possibly hang on. That's one thing you got to look out for. And of course, these are terrible, these right here. They work. If you have a main chute parachute at 300 feet, no problem, as long as your rocket isn't coming down at a high velocity. I have a little
Figure
link.
one's my go-to.
Yeah, it works all the time.
Just start with that.
Yep. On this, I have some links right here for bowline type nail knots. It's a case by case scenario on a bowline knot. It's very easy to make, very strong knot. We have a figure eight lock. I'll be showing you a few of them here in a few minutes here. These are very good links to look at on how to tie a knot to a quick link or any part of your points of connections. Securing the tail end of a knot is beneficial to keep it connected. Usually take some electrical tape and tape the tail of the knot. Not that it may not come out, but it shouldn't slip out, and it won't slip out. I've had pretty good success, and so has other people, and I think this is used quite a bit. This one here is a figure eight. Now this is the bowline knot. Here's a figure eight knot. It's a double figure eight knot, very secure. You can even double up this knot, the first knot, if you have to. The high power rocketry competition we're in now, these are very secure type knots using it. And of course, here you can see this is a 4-inch body tube, plenty of room for a redundant system with your European terminal connections and a very strong U-bolt connection. Oh yeah, this is a single half hitch knot, which is it's sufficient. It's pretty good knot. So far, I have not had any knots come out. I've flown many rockets that have not came untied for some reason, and they shouldn't.
There's one knot that I found is typically you don't want to attach the parachute right at the nose cone or right at the electronics bay. You want to attach it somewhere along the length of it. And one that I've found recently that I really like for that is an alpine butterfly loop that you can make that attachment spot in the middle of the line. And it's real quick and easy to tie. You can put loads on all three directions, and it's pretty easy to untie if you need to move it.
Yep. Recovery, deployment canisters positioned directionally forward in the booster section. Right here are the little satellite deployment charges I was talking about, where it blows out the recovery system. Probably the person I was talking to probably knows about Davy rockets. I have used them to clip them on here, and the canisters fit right on there so they don't move. Here's your typical fiberglass. We'll go over here first. Example number 2 has your canisters on the forward, and there's no canister shown here, but you put a canister on the back end here for apogee, and here's the one for your main. Of course, this is your AV bay with your vent hole and switches. Of course, this is the worst scenario you don't want to happen to your rocket. When your rocket deploys early during ejection, or it deploys really late after apogee. This is called a zipper. And basically, this should not happen to a fiberglass rocket, but I've seen it happen to a fiberglass rocket, but not too often. But this is your basic craft paper tubing. Here we have a fiberglass nose cone. I have the Ford's eye bolt on here. And these are extended bolts on here because I put weights on here. as they go, as I can clip them on and bolt them in for what I need on the type of motor I'm going to use, as shown right here. When you do epoxy a bulk plate in a fiberglass or even a polystyrene type nose cone, always go right above the shoulder of the nose cone because you have a reaction happening as the epoxy bonds to this plastic. It'll heat up a little bit and you could get a warp just on the edge of that shoulder and you won't be able to get your rocket seated, your shoulder seated all the way onto the airframe. Just a note.
And if there's a shoulder in that nose cone that you can get it behind, that's even more positive engagement between that. So you can turn it sideways, slip it in, and then rotate it flat behind that shoulder. Then you're actually pulling directly on the plastic, and the glue is just basically there to hold it in place.
Energetics and deployment standards. We use 4F black powder. It's very fine. Provides peak performance during deployment. That's in figure 1. This whole figure, and this is black, the 4F black powder right here. Figure 2 shows the E-match with a cardboard tube wired to a European type deployment charge. You can do it in this fashion here, or you can do it in the satellite fashion where you push the laundry out. And you can see the European connections are connected to this. Try avoiding using these through the bulk plate and directly wired to your electronics. Always use a separate connection. I know too many connections make a certain hazards, but this makes a good connection. And of course, if it's not connected, you're not going to get the right sequence on your altimeter, correct? But you don't want any of these wires getting stuck on any deployment recovery harnesses and pulling out and pulling on your altimeter and destroying your altimeter or parts of your altimeter or your sled coming apart.
And you also, when you're passing past that wiring through the bulkhead, seal that up.
Yep,
because
right
you
here.
don't want your ejection gases being pushed into your electronics bay. It can cause malfunctions, but it'll definitely cause the black powder residue is very corrosive. So any metal parts and screws and stuff in there, you don't want that around your electronics.
Right. There's a diaphragm on your altimeter, which reads your barometric. It's kind of the brains of your altimeter, and it reads your pressure, and the black powder can contaminate that too, along with if it gets wet, high moisture content.
Yep.
And it gets out of calibration pretty easy.
So yeah, you don't want any of those gases leaking into your bay. So
yep. Figure 3 here. It's just an example of just a paper pack. We don't use these. Usually it's used in low power or mid power type rockets in case you don't have any of these tubes. I've used these with success. Of course, they got to be packed pretty tight. Here's your igniter deployment and your black powder folded real tight and packed. It's kind of handy. It works good. But we basically use those in smaller rockets. Of course, here's the cardboard tube. Go ahead.
The small centrifuge tubes work well too.
Yep. Here's the cardboard tube with I got number 3 written on there, 3 grams of powder. These cardboard tubes will hold up to 5 grams. Here's the E-match that is inside of this tube. Some people have luck with the latex type finger deployment charges. If you have a small cardboard tube rocket, 4-inch or smaller, and it's laying on its side inside the tube, this gives you some pressure to deploy your rocket, but it won't blow a hole in the side of your rocket open as much as a cardboard tube could possibly. That's why
I've done that with a centrifuge tube as well, blowing a hole in the side of the rocket.
Right. That's why I put these cardboard tubes straight up. They don't move at all.
Well, you can use if you want to, you can put the cardboard tube or centrifuge tube in a charge well to keep them oriented correct. I've got one of my friends that does that. And if you
Right.
3D print your charge wells, do not print them with low infill. Print them with 100% infill.
Right. They'll shatter on you.
That's not somewhere to save weight if you're
Right.
printing your charge wells.
Of course, it's a ball plate mounted canister. Typical. A lot of people use these. Works good. Works well. And then,
And
then
that's
again,
just a
of
little
course,
piece of PVC pipe there, isn't it?
yep. And again, of course, always seal your holes that go into your AV bay.
Yeah. Shell cartridges are also something that's used. For smaller rockets, you can get a 9mm or a 44 Magnum. Just a spent shell casing. You can use that.
How did you know I had that gun? Okay, internal deployment devices. Basically, we don't use these type of CO2. You can. They're cool. They do work. I've seen quite a few people use them with success. They're a little pricier, and there's a little more mechanics to hook it up, to hold them in quite rigidly. Of course, here you have your igniter, and here you have the needle plunger, and you have black powder in here. And once this is all together, your electronics will indicate that, oh, it's time to deploy. This little plunger here will pierce this CO2 cartridge, and air will enter this chamber right here where these holes are and create a nice good pressure. I think you can get them up to almost 10 grams of pressure as you would with a black powder.
Yep. The one place that is indicated is if you're at very high altitudes, where the lower pressure will impede the way that your black powder will burn. You're not going to get anywhere near the altitudes that you need that. So the black powder should work fine.
Yeah, black powder works pretty much 40,000 and below.
Yeah.
Of course, here's the cardboard tube, and then here's those little canisters or flasks they use that he was talking about. I don't know if they sell these anymore. Do they still sell these anymore?
Centrifuge tubes, you can get them off of Amazon, and you just drill a little hole. I think I use a 5/32 hole that I drill in the bottom of them. It's just enough for the wire to slip through.
Yep.
And if you really want to be super careful, you can put some silicone or epoxy or something around the wire. But the one thing, if you decide to use those, that I will caution you is I would cut the caps off
and tape them.
And you can put a little bit of wadding in there and then tape over them. Yep. That's how I put a hole in the side of one of my rockets. I shot the cap through the side of the rocket.
And of course, here's your basic deployment well canister mounted on the AVX. This I don't caution you, but the trick of these, to get the maximum blast out of these, you have to pack them tight. We talked about putting wadding in these, and we do, and wadding in here. And once you put wadding, you apply pressure to the black powder. And once you applied pressure, of course, you tape it down securely and make sure that it is totally packed tight. You get a really good proficient charge out of it then. I've seen people put black powder in there loose, and it just goes poof. It doesn't go bang.
If you go the route of packing it tight, though, you need to practice that so you can be consistent at it.
Yep. Yeah, there's no tool in the world that can, well, loading could do it, but no tool in your hand can do it properly unless your instincts can do it right. Okay, external main deployment. Some operating altimeters are attached externally tagged with a harness and parachute. The Jelly Logic, and I believe they're not allowed in the competition. Jelly Logic altimeter. We just had they work okay. I've seen a lot fail more than work. Um, I had a launch this weekend, and a guy flew his rocket 5 times, and it worked 5 times. I couldn't believe it.
Most of the times I've seen the failures, including my own with this, has been operator error.
Yep. Yep.
And you can daisy chain two of these and
Mhm.
get redundancy from them. So you have, one of these on one side of the parachute, one on the other side, and they're hooked to each other. So if either one of them turns loose, it'll work.
Right. I've seen an issue where it's the rubber band was too loose and the rubber
Yep.
band was too tight where it didn't
Yep.
release. So it takes that instinct again to know,
Yep.
how far to go with it.
If it's too
This
tight, it'll jam and won't release at all. If it's too loose,
right,
it'll deploy at apogee, which you don't want either one. The other one
right.
is people will ground test it and forget to rearm it.
Exactly. It's in a standby mode. Yep.
Yep.
Here we have the cable cutter, classic cable cutter. I've seen a few people use those at high altitudes, and they work good as long as your cable cutter's got a sharp blade on it, and you have kind of a cheap tie wrap. All it is just a razor blade in here, and a black powder behind it, and you have your altimeter wires right here with the igniter in it, and it just blasts forward and cuts uh, the tie wrap. And of course, that's wrapped around your chute in the same manner as this is.
And again, you can get redundancy there by putting two of them on the same tie wrap.
Yep. And it's very compact.
Yep.
Okay, parachute preparation. This is just a standard type parachute fold. We all have our little nooks on how we fold our laundry, right?
Everybody
Here,
does it differently.
yep. Myself, I just do the burrito roll, and I'm good with that. It seems to work most of the time. Here we on figure one. Of course, always straighten out your
Shroud lines.
canopy shroud lines. Yes, thank you. Shroud lines. Make sure they're not tangled up. You can fold your parachute 2 or 3 times in half like this without tangling up your shroud lines too bad. Take some of your shroud line and loop it inside, fold it in half, and you do like a half burrito roll on it. They call this fold. Your chute will pop real quick once it gets out of the barrel in this position here. And here we have the cloth, the protection parachute protector, which you should put around your parachute once you've folded it up properly. And you fold it up in almost like a burrito shape and throw it in the aft end of your or not the aft end, the forward part of your sustainer section or your booster section.
And
Of course,
you literally roll that up just like you would a burrito.
Yep. You can roll it up as tight as you want, just as long as the shroud lines are secure. I like these chute protectors nowadays. Back in the old days, all we was using was dog barf, and at least the chute protector holds your shroud lines and your chute in one state. Because before, when the chute just laid in there, things would get kind of tangled up. The chute would go into the shroud lines, and the shroud lines going into the chute, and you end up with a tangled up chute sometimes. So using these chute protectors saves your chute, and it secures it very, very well, and it does deploy very well after its time. Number 7 here, we have a recovery strap. Sometimes you'll have an extra long recovery strap, and you're like, oh, this ain't gonna fit in here. If you do these little S curves like this, every 10 to 15 inches or so, it'll fit perfectly in there. And as your rocket deploys at the proper apogee and speed, it gradually snaps this tape open and this tape open. It has a nice gentle release of the shock cord. And of course, when I say tape, this is masking tape, one thickness of masking tape. Don't take the whole roll and wrap it around it because it will not release. I've seen people come to the launch with it rubber banded up and they forgot to take the rubber bands off.
I figure 8 and rubber band mine.
Okay. Oh, Where do we go here? Here we go. Okay, keep your rocket together. Especially you're going to be doing dual deployment. You must use shear pins on your main deployment rocket. I guarantee it. As the rocket goes up and it deploys at apogee, your main chute may come out because your nose cone may come out. This is just showing these are just showing the rivets for your AV bay. Here it is on your nose cone. And these are push-in type rivets. They make 256s, and I think they make some kind of 440s also,
Yeah,
which are a little
yeah.
thicker.
Just
And
two
these are
different.
your
Those are not just standard nylon screws. There's nothing special about these. They're just a 256 or a 440 nylon screw.
these are rivets that you may want to use for your payload section. They do not supposedly not break apart. They're not supposed to break apart. These are releasable by your techniques of using a knife or a pliers, so you can open up your AV bay to get it conveniently, operable for your installing your batteries or your AV bay or your taking your sled out. But I do.
For the cardboard rockets, these rivets work really well.
Mhm. I recommend always using shear pins for your main chute deployment because as your rocket goes up, your rocket deploys at apogee. You want to make sure your nose cone stays on, holding your main in. And of course, as your rocket comes down from 4,000 feet, your rocket may be doing some spinning and your chute may be knocking at the back door of that nose cone and loosen your nose cone off and fall off. So you want to make sure that these shear pins are in your rocket. At least 2 to 3 shear pins should be sufficient for a 4 to a 5.5 inch diameter rocket.
It takes around 35 pounds of force to shear one of these.
On your RockSim program, there is a new tool on there. I think it's under rockets on the tab, upper left hand tab, and it's the bottom tab on that tab, and it shows rocket deployment, and they will calculate how many square inches of volume is in that area for the black powder to be used, how many grams to be used in it, and it also gives you a choice of what type of shear pins you're going to use. But then, of course, after everything is said and done, they always say ground test, ground test. And that's what you should always do. Locating your rocket without a tracking system. You or a team member should watch the direction where the rocket lands. Mark it on the gravel that you're standing on where the rocket landed, or lay a straight line object on the ground, pointing in the direction the rocket landed. I know you might have a fancy GPS or RF system in that, but you should always watch where your rocket lands in case your electronics fail on your GPS or your RF. Pick a landmark, of course, where the rocket landed. A tree, a pole line. Pick the landmark in line directly behind you also, so you can mark two points of the direction behind you, in front of you. Always keep that in mind. To enhance this manual technique, you can even have a person who has a line on the rocket, stay at that location, send another person, B, to retrieve the rocket. Of course, person A should have a phone and person B should have a phone or a walkie-talkie. Walking a straight line with direction with the person. A, if the terrain is obstructed by brush or small ditches and lines, have the person B carry a small marker or a flag or something if you want to. So if they get too far, you can actually see them. I know it sounds ridiculous. We've seen people do this and it actually works, especially the terrain you're going to be flying at Richard Bong. Oops.
And if you got two observers, they can both watch and you get both direction and distance out of that.
Yep. Taking a video of your rocket landing as it descends gives you another mental mind of looking at it several times, so you know you're going in the right direction. Also, of course, a small audible sonic beacon will aid the location of your rocket as you approach when you're only getting close. You cannot hear it from where the rocket took off, but it'll give you a sense of direction. It'll give you a little satisfaction on it besides using your GPS. Do not use a audible sonic for a location during this competition. You must use a GPS or RF type device, but you may add an audible sound to it. Using a
That's
smartphone.
the little bit sound beacons at Bong would probably be a really good idea with some of the grass there, right? If that's permissible.
Yes, it is. Using a smartphone with a compass with an app works okay too. You can open the compass app and just click on where the rocket direction landed, but you must stay at that same point and make sure you look behind you and in front of you of all landmarks and your phone toward the landing area and click the compass heading. Walk in a straight line to the landing area and keeping a lookout for obstacles and maintain a straight heading with landmarks observed when the rocket lands or where the rocket landed. Always assume the rocket may have landed further than you perceived. And please always go by that rule because it is a lot farther than you think. Transmitters, receivers, and GPSs. Communication specialists, a lot of us have those, but they don't sell this on the market anymore. It's not available. I think they do sell it on Amazon or some other
There's
places.
some used ones.
Yeah. The receiver is good. It's a good receiver. Transmitters, they get worn out and weak out. There's a specific person that does make new transmitters for these, and they are available. And of course, we have the Yagi directional receivers. I've used these. They work quite well. But
And
these are
you can use the same transmitters with both the Yagi
yep,
and the ComSpec
right.
receivers.
And using RF type devices, always look where your rocket landed because your signal might get weak and you'll go, oh, what happened to the rocket?
And these take some practice to get proficient too.
Yep. I probably told this story 100 times already, where I had a rocket go up and the main came out at 8,000 feet. And it was a calm day, open farm field. You know, I looked at it. Oh, I got it. I'll drive to it. Well, I got my vehicle and I drove, and I 20 seconds or 15 seconds later, I went to see where it was. I couldn't see it. I'll keep on these devices, and I'll let you the ending story of it. Okay, featherweight GPS trackers. We have a lot of flyers where we fly. Use these. They work very well. They are smartphone compatibility. They can talk to you and show you the direction to walk to. They work really well. I've seen people go at least 5 to 10 miles to recover their rocket in a forest, and they actually found it, which I don't know how they did it, but they did. We have the Egg Finder GPS tracker. These work very well if you've wired it right, and it has good telemetry.
Yep, that's a TX you've got there, not a TRS.
Yep.
TRS are no longer produced. The Quasars are a replacement. I
Quasars,
use
yeah.
Egg Timer for everything,
Good.
and I have tracked a weather balloon to 75,000 feet with one of these.
Mhm. Okay. Safe recovery is always a permanent thing. Sometimes you have failures. This is a Kato of a motor. And of course, here's me recovering someone's rocket out of a tree. And as I said before, I lost track of my rocket because of power lines. I had an RF receiver on it. Power lines and farm machinery were running. And I couldn't get a good fix on it. So I asked somebody that was watching my rocket. Oh yeah, it landed between that fern tree and the silo, and there it was, right there, laying in someone's front yard. Of course, this is not a perfect recovery right here. Do not attempt to recover any rocket in any lines. Okay, any questions? Sorry, I ran a little late. Did a lot of talking. Any other questions?
And if it goes on the power lines, you call the utility company and they will come out and take them off.
Yep. Any questions, anyone?
Covered everything?
Everything.
All right. Well, if there are no questions, thank you guys for joining us. But
Cool.
if you have
Thank
any
you,
that come
guys.
up, feel free to reach out. But otherwise, have a great rest of your evening.